Did you come in just last week, or have you been here for a while? I got so many people I don't even remember. Hi, Ty. Hey, Janaya. How are you? Everything going okay? Hey, Kamaya. How are you? How was your weekend? I'm good. Yeah, I'm good. Had a nice weekend. Saw my son in Grand Rapids. How about you? Did you guys get more sleep? Were you able to rest more? Everybody's just good, just good. Too many questions, huh? All right. Well, that's understandable. Tanisha, how are you? Good to see you. Let me put my settings up here so that I have notification of people joining and chat messages save, because I'm going to open up a breakout room later on and going to help people get their grades up. So just to let you guys know. So what we're going to do is we're going to take a pre-test. So a pre-test on the periodic table. So going to give you about 10 minutes here, pre-test on the periodic table. So the pre-test is going to be, again, like anything, you're not supposed to, we're not expecting you to know um, a lot about it on the periodic table pre-test. It still counts as points or bonus points. It'll help me out because this is our professional development to see if we can improve retention in vocabulary and science. All right, so I'm going to give you that real quickly. So we're going to take about 8 minutes to do that. Let me get that for you. It's in here. I'll give you the link. It's in week 8 pretest. So the pretest looks like this. Give you 8 minutes. I'll put myself on pause. I'll have to remember that I am on pause. So pretest, just give everybody knows how to take a screenshot of the assignment. The score, remember the score does not matter. Score does not matter. If you can get in there, score does not matter. So we'll have a post test on the same thing. So the better, it'll give me information as far as whether or not I'm going over the vocabulary correctly or not, or how best to improve particularly the vocabulary. Okay, so if you guys will get in there, I appreciate it. Make sure that you put down that you are in PS6. That'd be great. Like I said, I'm going to put it on pause. All right. Thank you very much for those people. We got about 6 people in there. I see we got some latecomers. Hey, Lena, and let's see, was it Joseph and Brent? Brent, you guys came in a little on there. So if you guys get a chance, get this in before the end of the day. Okay, I'm giving you time because I need the data on this. All right, so let's take a look at what we're doing today. Okay, and today what we're doing is we're doing the history of the periodic table. That's why I had to do the pretest first. I did it wrong in the first hour. Pretest came after I gave you the quiz, or after I gave you the information. So let's do this slideshow here. Oops, escape. Oh, and I also have to do this. I forgot that I gotta do because there's a video in here. I have to show you so you can listen to it. Okay, share. All right. All right. So this is the history of the periodic table. Now, periodic means a pattern that repeats itself. A periodic table, like this day comes, sunrise and sunset. It's a pattern that continues. So that's what the periodic table is about, patterns that continue. So given the necessary information to determine the mass number, number of protons, and number of neutrons as an element is given. So getting that information out of the periodic table, that's what we're interested in. All right, so the periodic table elements, it puts all the known elements into groups with similar properties. This makes it an important tool for chemists, nanotechnologists, and other scientists. If you get an understanding of the periodic table and learn to use it, you can predict how chemicals will behave. So we're going to look at the big blue button a lot for conference videos, and we're going to practice in class. All right, so okay, if I ask you a question here, let me clear out the chat here. All right, in the private chat, let's do this all together in 10 seconds. All right, tell me where the neutron is. Is it A, B, or C? In 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Everybody put the letter in. Put a letter in now. Okay, that's where the proton is, you guys. Proton is A. I asked for a neutron. Anybody know where the neutron is? Okay, thanks, Janaya. C is the neutron, right? Yep, C is the neutron. So again, remember the Bohr model? This is something that we're going to be talking about. We're going to stop using the Bohr model and we're going to be using the periodic table. So this is pretty information. So let's look at that. Protons are the positive charge. The nucleus has the mass of most of the atom, has the protons and neutrons. Neutrons are zero charge. Protons are positive charges. Electrons are the negative charge that go around in orbits or clouds, right? And the proton is important for how the periodic table is connected. So there are 118 known elements in the universe. The periodic table organizes all the elements in a way that is understandable and useful. Remember, elements differ by number of protons each has it in the nucleus. Okay, so number of neutrons does not change the element. So one proton in the hydrogen, two protons in the helium. We could put more neutrons in there and it would not change what they look like. Right, so there are different atoms, oxygen, carbon, sodium, hydrogen, all have different atoms. They're made of different types of atoms, but it's the protons that are found in the nucleus that give its identity, or what we call the DNA. So the current periodic table has 118 squares. Carbon, we look at this square, has the name, it has the atomic number, and the atomic mass, and the symbol. So let's take a look at that quickly, the information in each square. So let's take a look at helium. Helium has the chemical symbol, capital H, lowercase e. The capital is always the first letter in the symbol is always capitalized. The second letter, if it has one, is always lowercase. The element is listed in the words underneath, element name. And the atomic number is 2 in helium's case. It's the number of protons or electrons. So if you know the proton, that the atomic number is this one, then you can put down how many protons it has, and you can also tell how many electrons it has in a neutral atom, because protons, the number of protons, if they're the same, they'll cancel each other out. And then the atomic mass is the protons plus the neutrons. So in this particular case, if we were to talk about this, all right, so again, remember, this is the protons or the neutrons, or I'm sorry, or electrons, not neutrons, electrons. Okay, so if I were to draw this atom, they would have 5 protons, 1, 2, 3, 4, 5, right? And then it would have 2 shells around it. Ooh, looks like a ghostly face. There's an electron here, electron 2 in the first shell, and then 3 in the last shell. 1, 2, 3, right? And here it says, now this is always a whole number. Okay, this is the bigger one. This is your atomic mass. Atomic mass. Okay, and we round that. So we're going to call that 11. Subtract the 5 gives me 6 neutrons. So I've got 1, 2, 3, 4, 5, 6. That's what my atom looks like. Boron's the name, and that's the element, so forth there. Okay, so let's look at a helium atom. They do a little bit better job of drawing pictures here. So the protons inside the nucleus, positively charged. The electrons, so the number's the same for both protons, electron, for a neutral atom. So they cancel each other out. This positive cancels out this negative. So that's what we call a neutral atom. Okay, proton or electron. Helium has 4 in the atomic mass because we're counting up all the parts in the nucleus, protons and neutrons. 2 protons, 2 neutrons. Before the periodic table, it was a mess. Back in the 1800s, there were roughly 63 elements that not organized. It was difficult to locate the information of all on the elements and predict how they would react. So that's what the periodic table is good for, predicting. So let's watch this video. Tell me if you hear something. Anybody could say that they hear or not hear, I'd appreciate it. Oh, thanks, Christian. Thanks, Janai.
The periodic table is instantly recognizable. It's not just in every chemistry lab worldwide. It's found on t-shirts, coffee mugs, and shower curtains. But the periodic table isn't just another trendy icon. It's a massive slab of human genius, up there with the Taj Mahal, the Mona Lisa, and the ice cream sandwich. And the table's creator, Dmitry Mendeleev, is a bona fide Science Hall of Famer. But why? What's so great about him and his table? Is it because he made a comprehensive list of the known elements? Nah, you don't earn a spot in Science Valhalla just for making a list. Besides, Mendeleev was far from the first person to do that. Is it because Mendeleev arranged elements with similar properties together? Not really, that had already been done too. So what was Mendeleev's genius? Let's look at one of the first versions of the periodic table from around 1870. Here we see elements designated by their 2-letter symbols arranged in a table. Check out the entry at the 3rd column, 5th row. There's a dash there. From that unassuming placeholder springs the raw brilliance of Mendeleev. That dash is science. By putting that dash there, Dmitry was making a bold statement. He said, and I'm paraphrasing here, "Y'all haven't discovered this element yet. In the meantime, I'm going to give it a name. It's one step away from aluminum, so we'll call it Eka aluminum. Eka being Sanskrit for one. Nobody's found Eka aluminum yet, so we don't know anything about it, right? Wrong. Based on where it's located, I can tell you all about it. First of all, an atom of Eka aluminum has an atomic weight of 68, about 68 times heavier than a hydrogen atom. When Eka aluminum is isolated, you'll see it's a solid metal at room temperature. It's shiny, it conducts heat really well, it can be flattened into a sheet, stretched into a wire, but its melting point is low, like freakishly low. Oh, and a cubic centimeter of it will weigh 6 grams. Mendeleev could predict all of these things simply from where the blank spot was and his understanding of how the elements surrounding it behaved. A few years after this prediction, a French guy named Paul-Émile Lecoq de Bois-Baudran discovered a new element in ore samples and named it gallium after Gaul, the historical name for France. Gallium is one step away from aluminum on the periodic table. It's Eka-aluminum. So were Mendeleev's predictions right? Gallium's atomic weight is 69.72. A cubic centimeter of it weighs 5.9 grams. It's a solid metal at room temperature, but it melts at a paltry 30 degrees Celsius, 85 degrees Fahrenheit. It melts in your mouth and in your hand. Not only did Mendeleev completely nail gallium, he predicted other elements that were unknown at the time: scandium, germanium, rhenium. The element he called eka-manganese is now called technetium. Technetium is so rare it couldn't be isolated until it was synthesized in a cyclotron in 1937, almost 70 years after Dmitri predicted its existence, 30 years after he died. Dmitri died without a Nobel Prize in 1907, but he wound up receiving a much more exclusive honor. In 1955, scientists at UC Berkeley successfully created 17 atoms of a previously undiscovered element. This element filled an empty spot in the periodic table at number 101 and was officially named Mendelevium in 1963. There have been well over 800 Nobel Prize winners, but only 15 scientists have an element named after them. So the next time you stare at a periodic table, whether it's on the wall of a university classroom or on a $5 coffee mug, Dmitri Mendeleev, the architect of the periodic table, will be staring back.
Okay, so Dmitri Mendeleev in 1869 created the periodic table. Mendeleev was a chemist and professor who found a new way to organize elements. By writing he was writing a textbook, and then he used tried to solve a way to organize them. And what he did, because he was a card player, he tried to solve the puzzle. He spent time collecting information about all the numbers or all the elements and made cards of them, a deck of playing cards of elements. On each card, he wrote element's name, chemical symbol, atomic mass, physical and chemical properties, and bonding power. When he placed the elements in order by increasing atomic mass, now here's the difference. Today's atomic periodic table is by protons or atomic number, but because the proton was not discovered yet, proton not discovered, so proton is question mark, they used atomic mass. And then he noticed that it began to notice clear patterns, and the clear patterns are why they call it periodic table, the periodic table. I can't say it today, periodic table, because the pattern that keeps showing up, clear patterns that keep showing up. So the periodic table is why they noticed that. And so what he did, he placed the first 7 elements in the row. So he put lithium, beryllium, boron, carbon, nitrogen, and oxygen, and fluorine in the first row. Then he put the next in the second row. And then he noticed that the properties repeated perfectly. Now, the properties repeated in what they call the columns, not the rows. So they repeated in the columns. That's why columns. So that's why lithium and sodium in one row, they repeat. So these are metals. Okay. They have one valence electron. Remember, that's a 1 electron in the outermost shell. And then beryllium and magnesium have 2 valence electrons. They're both metals and so forth. So bonding power was talking about the valence electrons. They're So those are the interesting things about those and how they're organized. He filled the rest of the table and left gaps, like in the video, to show that he left gaps where the pattern didn't fit. So he moved like one of these over. It's like, hey, there should be something in there. So he claimed that the missing elements would be found and even predicted their properties in great detail. I could do this since I discovered that elements had the same vertical columns. Remember, we're talking about not rows, but the columns. The columns, as we go down, this column, everything's very similar to one another. Properties repeat each other, repeat throughout the column. So that's why the different colors. Okay, so we had some question marks. Eventually, these elements were discovered, and in my prediction, they were nearly perfect. Bold predictions. Dimitri's table was very accurate. The idea to put the test was that gallium was discovered in 1875, and this scientist, we'll call him Paul because I can't say that long name, discovered gallium and published information about the metal. Mendeleev publicly told the scientist that his measurements of her gallium or density were incorrect and he didn't match his predictions, and he was right. So a modern equivalent to that kind of talking back and forth, he took a huge risk challenging this Paul about gallium. The best way to imagine it in Mendeleev time in 1875 would be, in modern context, would be a Twitter war. So if you think about a Twitter war, Paul says, I just discovered new metallic element, gallium. The chemists say, great job, Paul. Give me some of the properties. And he said, well, it's a shiny metal, low melting point, atomic mass 68.53, density 5.6. And then Dimitri says, your data on gallium is wrong. 6 years ago, I predicted that it would be 69.73 and 5.9. Oops, that's a smackdown for you. And then Paul writes back, are you saying that the imaginary gallium is correct and my real gallium is not? What are you saying? Who are you? Back in the lab, Paul discovers, oh, I was wrong. The new atomic mass was 69.73 and the density was 5.91. Oh, hey, and then so dang, so the chemist, tell us about your table. How did he do that? So I can predict the table. I call it the periodic table. You can hang a poster about it in your lab one day. So now as time went on, there were some errors, but once they, Rutherford, and if you remember the gold foil experiment, he discovered protons. Then Moseley rearranged the table by atomic number, or the number of protons, hashtag P, instead of atomic mass, which was protons plus neutrons. Okay, so that is a new improved periodic table. Moseley's is very similar to ours. Okay, you have hydrogen on as element number 1, and then helium here. So this is what we're going to be talking about this week, trying to understand the periodic table and how to use it. We'll be using it more and more. Okay, so what I would like to do is stop right there. Okay, and we've got about 30 minutes left, a little less than 30 minutes, maybe 25. And what I'm going to do is, let me show you guys. Okay, so what we're going to do is we're going to, what I'd like you to do is go to your modules. And you've got enough information from today's assignment to do the 7 questions, or the 6, I think it's 6 questions for W1 assignment on the periodic table, W8 assignment 1. So here's the link for that. So if everybody can get the link here, tell me if it's working. Make sure I've got that in there. Now, the other thing that you probably want to have, let me close these out here. Okay, open up a new tab and go to this assignment, over in the modules on your courses 6, you should have a graphic organizer. Goes over just the information for this assignment. So let's take a look at that. Okay, if you go to the modules, you will see that when we get down to week 8, all right, it says atoms in the periodic table. All right, so here we go. So if you use the graphic organizers W8 as assignment 1, okay, so now what I can do is I can use the square in the corner here. I can make it half size so I can make it smaller or larger, right? Make it small. Now I can peel this one off and I've got the assignment side by side. Okay. All right, so you guys got about 20 minutes. Now there's also a bonus exit quiz. So you got 2 things you can do, right? So everybody, were you able to get in, Jeremy, into the assignment? So nice thing about this is that you could blow this up. You can make it bigger. So basically I have about 2 slides with about 6 different slides smaller in there. So to help you out to do that. Jeremy, did you say it works? I need to find out if somebody says it works or not. Are you able to get into the link? Anybody else get into the link? Okay, it does. Thanks so much, Christian. Okay, so what I'm going to do is I'm going to open up a breakout room and hold a couple of people in. All right, I'm going to turn my screen off. I'm going to call some people into the breakout room. Now, the breakout room is where I need to work with people, and I really appreciate it if you watch when I put your name in the breakout room that you come in so we can work on something. Okay, I've opened up the breakout room. If you guys that I've asked about 4 people to join me. So if we could do that, I'd appreciate it. Watch for your name. Hey guys, have a good day. Still working with people in the other room, in the breakout room. So 271 days to your birthday. Okay, Christian, have a good day. See you guys later. Thanks for coming in. Bye-bye, guys. Bye-bye. Okay, so let's take a quick look if you want to, Brent. Let's go over the, let me let you be the presenter and show me your screen, and let's fix those up so that you can get those. You'll be a little late for your class, but let's fix them. All right, so yep, let's just show me the screen there and we'll get those figured out. All right, so physical properties similar, properties. Okay, so that one is one you missed. So that should say the same. It says chemical properties are repeated between elements. So it's the second one there. Can you start it all over again?
I have a little bird.
Okay. All right, so that's 118, right? Okay. And that was Dimitri. Yep. And this one is the properties were the same, so similar, that's number 2. Properties are similar. And then properties repeated between elements. So that's the second one, the one underneath that. Yep. Because that was there. And this one was, do you remember which one this one was? Yep. Great. Next one. All right, so the element name is, yep, atomic mass is, nope, that's the atomic number. So this one's atomic, this one's D. D, the atomic mass is bigger. So when I think of atomic mass, I think of massive. It's bigger than, and then element, yeah. And protons and electrons, B, but put B on that one, right? Yeah, there you go. All right, Mendeleev left gaps in the periodic table, did not fit, because he knew that missing elements would be found. That's letter A. And they were in columns, right? Not rows. Great. Let's see how you do there. All right, good. All right, well, you have a good day, and I will see you tomorrow.